I'm going to do an example of a Leontif input-output model for an economy. So in our economy, we're going to be making just food, clothing, and shelter. Each unit of food, clothing, or shelter requires the consumption of some of each of the rest with the numbers provided. And we want to know how much we should produce to satisfy the given demand. So first, we're going to come up with our input-output matrix. Each column represents a line here that tells us how much we need to make food, clothing, and shelter. So to make food, I need 0.1, 0.3, and 0.2. To make clothing, I need 0.3, 0.1, and 0.1. And to make shelter, I need 0.4, 0.2, and 0.3. Finally, we also need a demand matrix, which is going to be a column simply listing the 3 demands down. Now, to solve a Leontif input-output model, we are going to be using the formula. The X will be the identity matrix minus A inverted times D. So, first we're going to compute the identity matrix minus A. The identity matrix being the matrix with 1s down the diagonal and 0s everywhere else. Okay. From this, we subtract A to get 0.9 minus 0.3 minus 0.4 minus 0.3, 0.9 minus 0.2 minus 0.2 minus 0.1, 0.7. Okay. Next, we take this matrix, which I'm just going to call I3 minus A because I don't want to write it out again, and we have our calculator find the inverse of it. Okay. And this is what we get. Now, our last step is using our calculator to take that matrix here, which again, I'm too lazy to rewrite out, so I'm just going to call it by its title, and multiply it by our D matrix that we already have to produce this matrix. And from here, we can answer the question of how much should be produced. We need to convert back to millions of dollars. So for food, we should make 31,179,500. For clothing, we should make 31,794,900. And for shelter, we should make 36,307,700. And that is the answer to our question.